Hi to everyone. I am Dr. VNSR Venkateswra, working as a Associate Professor in Chemistry from Freshman Engineering Department in Institute of Aeronautical Engineering College. Today I want to discuss about the topic of the corrosion. In this topic mainly you discuss about the definition of the corrosion and what are the types of the corrosion and how to factors affecting the rate of the corrosion, and finally we'll see how to prevention of the corrosion. Okay, so corrosion is one of the surface absorption phenomena, is a branch of the physical chemistry mainly observed in the materials. So it is comes under category of the material science. See, most probably the iron material undergoes the corrosion whenever it undergoes the oxidation phenomena. Oxidation means ferrous is undergoes the ferric metal. That means whenever the ferrous absorbs the atmospheric oxygen and it forms the ferric oxide. Like that we observe in the copper also. Whenever the copper placed in the environment, it absorbs the carbonate and it converts into a copper carbonate material. So by taking these two examples, we explain the nothing but metals how to undergo the corrosion phenomena. So see, in the first one, the waste of the materials is open on the environment. By the absorption of the atmospheric oxygen, they undergoes the corrosion, nothing but rusting of iron. So it is nothing but a material science phenomena. Yes, corrosion is observed mainly in the case of the various types of the metals, nothing but it is defined as the degradation of the material due to reaction with the environment. Degradation means destroying the material and it can degrade the itself. That means wherever the oxygen takes place on the surface of the material, it undergoes the oxygen and it can lose the surface of the its own material. That means it can lose the physical characteristic properties by the chemical reaction. Chemical reaction is nothing but it undergoes a whether oxidation phenomena. Oxidation means loss of the electron and with this environment. Environment means the gases which are present in the oxygen, sulfur dioxide, carbon dioxide, whatever may be the gases reaction the surface of the material. Next one, environmental factors. Environmental factors mainly nothing but a temperature is one of the important phenomena. Whenever the temperature increases, it will be directly proportional to the corrosion. That means the rate of the reaction. Second one is the presence of the moisture. Presence of the moisture especially observed in the rainy season. Whenever the rainy season starting on the like a rain falls down on the material, it absorbs the corrosion, but wet corrosion is faster than the dry corrosion. And environmental factors in the case of the sea surrounding environment. Whenever the sea surrounding environment, the salt present in the surrounding the gases and surrounding environment is very very high. So the percentage of the electrolyte is more. So in the presence of the electrolyte, the rate of the corrosion is the more. So by taking these environmental factors like temperature, in the presence of the rain, nothing but wet medium, and in the presence of the environment, moisture content, the rate of the corrosion will be directly proportional. So corrosion in case of the most of the metals oxidized by the oxygen in the air. That means the main cause of the corrosion unwantedly gas is the oxygen present in the environment. So by the absorption of the oxygen from the environment and it degradation takes place, nothing but a oxidation. That means the process of absorbing the oxidation is nothing but a oxidation phenomena. So oxidation, nothing but a iron converts into a by the iron oxide by the absorption of the oxygen molecules, and it can absorb the water molecules, and it can be converted into a iron hydroxide forms and precipitates. Finally, the hydroxide quickly oxidizes to form a rust on the material of the iron. So that means Fe2 is nothing but a elemental phenomena, and it absorbs the oxygen and converts into Fe+3. That means ferrous to ferric. In case of the water molecules, it also absorbs the hydroxide and it converts the ferric hydroxide, water droplets. That is nothing but a electrochemical action driven by the energy of oxidation continues the corrosion process. And in the case of the corrosion phenomena, mainly you consider the two types of the electrodes. It is nothing but a electrochemical process. So both anode and cathode. Anode is the main electrode. The action causes the pitting of the iron. Pitting of the irons, see the phenomena, we observe the gaps. So pits nothing but the gap present in the surface of the material. So that anode action causes the pitting of the iron. So, and second one is the cathode. So cathode is the action reduces the oxygen from air, forming the hydroxide ions. That means always the metal placed at the anode should be undergoes the corrosion, whereas the metal placed at the cathode should be prevention itself. That means the metals all the present at the anode rapidly undergoes the corrosion. So in the presence of the oxidation phenomena, electrons leap from the metal to the oxygen molecules. Next one, the corrosion chemistry. So what is the chemistry linked with the corrosion? Nothing but it is the phenomena of the physical branch. That means physical chemistry. It is the branch of the physical chemistry. So the process is nothing but a corrosion is the oxidation phenomena. Oxidation is one of the chemical reactions observed in the chemistry. So what is the corrosion chemistry? Nothing but the negative ions which are thus formed penetrate into the metal, causing the growth of the oxide surface. That oxide surface shows the nothing but rusting on the material. In case of the iron, most probably we observed in the phenomena. That means what is the process of the corrosion? Negative oxygen ions which are thus formed penetrate into the material, causing the growth of the oxide surface. Next one, corrosion chemistry. The corrosion steps and metal is the made passive. So once the oxide layer growth on the rate of the electron transfer decreases. That means once the oxide layer produces on the material, the corrosion stops and the metal made is passive. Passive means inert. Further, it should not absorb the corrosion. This type of the corrosion mainly observed in the aluminum oxide. Al2O3, aluminum oxide. It further penetrate or allow the corrosion once the oxide is produced on the material. In case of the US, most probably per annum $276 billion are consumed due to the process of the corrosion. So first thing is the machine materials used in the wheel, and second one is the internal parts of the machines, and third one is most probably used in the oils, various industries of the phenomena. So in the case of the car, how to observe the corrosion in various parts? That means firewall and both liner and federers, all streams and lags and the hood, all winning including block and headings and bumpers, complete undercarriage and clearance lights, all streams, front fender brakes and behind chromate molding, door locks and handles, doors, rocker panels, shocker towels, wheel arches and lives, filter and cap door, dog legs and rear corner panels and rear frames, title light assembly, all seams and the truck lid and window pillars. So all these materials are caused the corrosion because of the absorption of the temperature and exposure to the environment. So all these factors comes under category of the environmental corrosion. So next one is the another type of the corrosion, nothing but a Rebar corrosion. So it is the second type of the corrosion, Rebar corrosion. So concrete damage due to Rebar corrosion is a common problem among the bridges and other saltwater structures. So because of the saltwater presence of the electrolyte in the presence of the because of the salt water, the salt present in the water and in the presence of the electrolyte, rapidly corrosion undergoes. That means the reaction rate of the corrosion should be faster in the case of the salt presence. That means salt presence means electrolyte presence. So in the presence of the electrolyte, the corrosion rate will be directly proportional to each other. So according to 1997 report of the nearly 581 and 862 bridges in the USA, about 1,01,518 bridges were rated as a structurally deficient material. So it is nothing but comes under category of the Rebar corrosion and bridge corrosion. So infrastructure repair causes the nearby cost of the $78 billion and it could be increased to much 112, nothing but $112 billion depending on the number of the years it takes to meet the objective. That means this is the cost of the infrastructure before starting the bridge of the material. So in the case of the pipelines, how to corrosion takes place. A section of the pipeline shows the corrosion. The pipe walls had thinned in the hollow areas of the pipelines. That means in the internal walls is rapid corrosion takes place because of the various elements interact with the inner walls of the pipes, especially in the medium of the wet medium. So corrosion is also observed in the electronics materials, nothing but in the case of the circuits and in the case of the laptop mobiles, in the case of the mobiles and in the case of the desktop systems, all are causes the corrosion undergoes the electronics material. Erosion corrosion. So erosion corrosion is nothing but due to the flow of the water molecules, especially observed in the gas basin. So this gas basin causes the flow of the material, causes the gaps present in the surface of the material. So that gaps is nothing but a pitting type of the corrosion. This pitting corrosion is observed due to the flow of the solvent molecules or any other liquid media flows through the surface of the material. So that is nothing but a erosion corrosion. So prevention of the corrosion is observed by coating the material with the paints. So especially in the case of the God Buddha, by the coating with the materials, nothing but paints, we can prevention of the corrosion takes place. And material selection. In case of the cars, especially to prevent from the corrosion, we use the mainly material nothing but a stainless steel. Because of the stainless steel material, it does not absorb the oxygen present in the environment is very less compared to the iron. That's why we use the outer material of the car mainly made with the stainless steel. So in order to select the material based on the objectives used in the environment, we can prevent the corrosion phenomena from the environment. So this is the another example, nothing but material selection in order to prevent the corrosion phenomena. So this large statue by Pablo Picasso in front of the Chicago City Hall is made of the weathering the steel that does not need painting in many broadly exposed environment. So because of the, in order to change the material made of the compound or any statue's material, even though it is present in the environment, it does not corroded. While observing the, in case of the stainless steel, the rate of the corrosion is less by made with iron elements. And another element is nothing but a iridium. So iridium is most probably observed in the plug sockets observed in the motor vehicles. So the motor running is very, very important in order to prevention of the corrosion, because of the motor means it the presence of the temperature running, and it will be linked with the engine oil. So in the presence of the engine oil and presence of the temperature, the rate of corrosion is very, very more. So in order to overcome these conditions, that plug pocket is mainly made with the iridium element. That means the iridium can be considered as the most corrosive resistant element. And another one is the barrier protection. So barrier protection is mostly observed in the ProGuard and black oxide and plated. So by the absorption of the black oxide material, it cannot further absorb the amount of the causes the elements from the environment. So it is nothing but a barrier protection. And third one is the protective organic coatings. So these protective organic coatings mainly observed in the materials which are used in the industry pipelines, and in the case of the gardens, and in the case of the and in the case of the another materials, so most probably used in the protective organic coatings. These protective organic coatings comes under category of the paints. So these paints will also helpful to prevent the corrosion from the surrounding environment. So protective coatings. These protective coatings mainly observed in the galvanizing steel and weathering the steel compound. So by the linked with the interaction with the steel, it should be very, very less rate of the corrosion compared with the iron will be coated with the objective materials. So this is the another method in order to prevention of the corrosion. So that is called the cathodic protection. So the rate of the corrosion reaction may be controlled by passing the anodic and cathodic currents in the metal. So while observed in the circuits on the left side, that is nothing but a direct current supply. So this direct current supply will be observed by the objective material coated in the material. So it is observed in the left side circuit DC supply, and pipeline should be buried in the bottom of the earth surface. That means nothing but a buried pipelines, and that will be connected through the DC current circuit anode. So this buried pipeline is nothing but a protective material, and this connected anode can be act as a conductive bond. This connected can be act as a conductive bed. So by the connection of these materials, anode and cathode, we observe in the electrochemical corrosion. That means because of that cathode will be connected to a DC power supply, that material should be safe side. So that material safe side, how to change that? Because of at cathode, what happens? The rate of corrosion is less compared to the rate of corrosion at anode. So the material which is more important and more essential that material can act as a cathode. So if the material can act as a cathode, we can product that material particular corrosion. So in the C area also we observe the both zinc materials at left side and right side. So that means that material can act as a zinc material that can act as a cathode in order to prevent from the corrosion material, even though the material present in the sea water. So most probably this type of technology can provide a long-term solution to the corrosion issues for both steel and steel reinforced concrete structure and concrete highway pavement subjected to premature failure as a result of the exposure to marine and designing salts. That means especially the materials which are always present in the water, especially sea or rivers or canals. This type of the technique is used. Those materials can be protected from the corrosion. And another one is the cathodic protection. It should be mainly observed in the bottom of the ship is nothing but a hull of the ship. The hull of the ship on the surface of phenomena observe the power supply, and at the bottom it is nothing but a anode assembly and reference electrodes. So these reference electrodes can be acts as a sensing mode on the hull of the ship. So it is very, very important whenever they move on a ship, those are protected from the corrosion. Why? Because the hull of the ship always in the presence of the sea water. So sea water is nothing but a electrolytes. So in the presence of the electrolytes, what happens? The rate of the corrosion will be more. Cathodic protection will also observe this can only be applied if there is a suitable conducting medium such as earth or water through which a current can flow to the metal and to be protected. And sacrificial protection. This sacrificial protection will also observed in the gas basins. The base of the gas basins nothing but these pillars always present in the seawater. So seawater means that means reactive metals like zinc or magnesium. So these zinc or magnesium elements are highly active elements in the case of the corrosion, and they can sacrifice their life, can act as a anode. So whereas the material iron, that base material of the fillers that can be protected because of the zinc or magnesium elements can sacrifice their metals. That means these zinc or magnesium metals is coated on the pillars of the iron. So because of the coating material always contact with the layers of the seawater, and they can undergo the corrosion. But the inner layer should be nothing but iron. The inner layer should be protected from the corrosion. That means iron can act as a cathode, whereas zinc or magnesium elements can act as a anode. So this anode materials always rapidly undergoes the corrosion, while compared to the iron can act as a cathode. That means because of the zinc and magnesium undergoes the corrosion and they can sacrifice their life, that's why these are nothing but a sacrificial anodes. Whereas the iron can be protected, that can act as a cathode. So because of the zinc and magnesium are the most reactive elements compared to the iron. So it is nothing but a sacrificial protection. So the reactivity of the elements can be explained by the galvanic series. In the galvanic series, we observe the platinum, rhodium, silver, copper and hydrogen, lead, tin, iron, zinc, carbon, aluminum, magnesium, calcium, sodium and potassium. That means where we move from the bottom to top of the series, that means those elements are highly reactive. So what are those elements? Potassium, sodium, calcium, magnesium, aluminum. So all of these elements most probably observed in the first, second and the third group of the periodic table. That means sodium, potassium, calcium, magnesium are called as a alkali and alkali earth metals. They are highly reactive. In the case of the corrosion also, the reactivity is same phenomena follows the directly proportional to each other. So after that medium corrosion takes place, nothing but the corrosion zinc, iron, tin, lead. That means we observe the in the case of the couple iron and zinc. So the zinc placed top of the iron, so that element undergoes the rapid corrosion compared to the iron. So zinc can always acts as a anode, iron can act as a cathode. Iron can act as a cathode. So zinc can act as a anode and iron can act as a cathode. So because of the zinc zinc always can act as a anode and it can sacrifice its life compared to the iron. So iron can act as a cathode and it can safe side element. So if the iron is most essential element, that iron can be coated with the zinc and zinc undergoes a rapid corrosion. So that can be explained because of this galvanic series, and this galvanic series explain the reactivity of the elements. And come to the bottom of the series, that means below the hydrogen, copper, silver, gold, platinum. So all these elements undergoes the rate of the corrosion is very, very less by previous elements. That means these elements can act as a inert elements in the case of the corrosion phenomena. That means least reactive elements. And this type of the corrosion in case of the observed in the following example, that means in internal boilers, and the type of the corrosion will also observed in the internal boilers and heaters. And it is also seen in the corrosion phenomena aluminum anode rod and magnesium anode rod. In case of the magnesium anode rod, rapidly undergoes the corrosion and color changes on the top of the rod where compared to the aluminum anode rod. And this corrosion phenomena is also found that the organic compounds capture some iron from the hydrothermal vents, enabling to be carried away in the seawater. That means the seawater, in the case of if there is any organic material that can absorb the organic compounds, further it proceeds the corrosion. That means iron having the property, once the corrosion layer formed on its surface, further it absorbs the moisture from the environment. It should be continuously corrosion phenomena. So iron trapped in this way does not undergoes the rusting phenomena. So most probably the scientist discovering the shiny iron in the ocean was like fishing a dry sponge out of a full surface phenomena. So iron is the limiting nutrient in most part of the oceans, meaning that its scarcity is the only thing standing in the way of the faster elements. So for the scientist, discovery the shiny iron in the ocean was like fishing a dry sponge of the pool, and iron is the limiting nutrient, is the most part of the oceans, meaning that its scarcity is only the thing standing in the way of the faster growth. Types of the corrosion mainly involves in the three types. Based on the reactions and physical states, there are different types of the corrosions. That means the reaction between the metal and the environment to give the corrosion product. That means degradation of the metal with the surrounding environment by the chemical reactions, nothing but corrosion. There are mainly three types. They are waterline corrosion, galvanic corrosion, pitting corrosion. Waterline corrosion or concentration cell corrosion. These are mainly two types, waterline corrosion or concentration cell corrosion. This type of corrosion occurs due to the electrochemical attack of the metal surface exposed to the electrolyte of varying concentrations or varying the aeration. The main theme of the corrosion is due to the difference in the concentration of the metal ions. Difference in the exposure to air or oblique oxygen, differential aeration corrosion. That means difference of the corrosion by the absorption of the environmental oxygen. That means if you can take in the waterline corrosion, best example for the water tanks on the top of the buildings. If the water tank is exposed to the environmental oxygen, the top part of the tank absorbs the more amount of oxygen. The bottom part of the tank absorbs the less part of the oxygen. Even the top part of the tank absorbs the more amount of oxygen. It can act as a cathode, whereas the bottom part of the tank absorbs the less amount of oxygen, even it can act as a anode. Because of the presence of the moisture, the bottom part of the tank absorbs the less amount of oxygen, it can act as a anode. Whereas in case of the top part of the tank absorbs the less amount of oxygen, but it can act as a cathode because of the due to absorption of the dry atmospheric oxygen. Next one, different in temperature differential aeration corrosion is the most common type of the concentration cell corrosion. When a metal ion is exposed to the different aeration concentrations, it has been found to be properly oxygenated of the metal becomes anodic and well oxygenated part becomes the cathodic. So this is the best example for the differential aeration corrosion or waterline corrosion or concentration cell corrosion. Next one, factors affecting the corrosion. These factors influencing the corrosion mainly two types. One is the nature of the metal and second one is the nature of the environment. So nature of the metal depends upon the mainly the properties, different properties of a metal are responsible for the corrosion. This type of the properties are as follows. First one is the position of the metal ion in galvanic series, hydrogen over voltage, purity of the metal, relative areas of the anode and cathode, and physical state of the metal, and final one is the nature of the oxide film. And first one we can explain the position of the metal in the galvanic series. By explaining this point, position of the metal in galvanic series, by taking the two couples. First couple is the zinc and iron, and second couple is the iron and copper. So in the first couple, zinc and iron, observing the zinc undergoes rapid corrosion while compared to the iron. Why? Because the zinc lies the top of the galvanic series compared to the iron. So zinc can act as a anode and copper can act as a cathode. But in the second couple, factors influencing the rate of the corrosion, first one is the metallic and second one is the environmental corrosion. In nature of metal, there are several properties depends upon the reaction of the corrosion. That means the various type of the properties of the metal are responsible for the corrosion. These properties are follows. First one is the position of the metal in galvanic series, second one is the hydrogen over voltage, third one is the purity of metal, and fourth one is the relative areas of anode and cathode, and next one is the physical state of the metal, and final one is the nature of the oxide film. So now let us explain the first point, position of the metal in galvanic series. This position of the metal in galvanic series means by taking the two couples, first one is the zinc and iron, second one is the iron and copper. So in the first couple, the zinc can act as a anode compared to the iron because the zinc lies before the iron in galvanic series. While in the second couple, the iron and copper, iron lies before the copper. So it can act as a anode and copper can act as a cathode. So this is mainly depends upon the position of the metal ion galvanic series, which can finalize the whether the metal ion can act as a anode and cathode. In the first couple, the zinc lies before the iron in the galvanic series, so it can act as a anode, and iron can act as a cathode. But in the second couple, iron lies before the copper in galvanic series, so it can act as a anode, and copper can act as a cathode. And second one is the hydrogen over voltage. Depends upon the potentials of the hydrogen of the metal ions corresponding series, it can act as a corrosion phenomena. And third one is the purity of metal. Purity of the metal means when purity of the metal is directly proportional to the corrosion. And fourth one, relative areas of the anode and cathode. This relative areas of the anode and cathode depends upon the ratio of the anode and cathode. If the anode is more proportional to the corrosion, if the cathode is inversely proportional to the corrosion. And fifth one is the physical state of the metal. This physical state of the metal mainly two types. One is rough surface, and the one is polished surface. In rough surface, the rate of corrosion is directly proportional, while in the polished surface, the rate of corrosion is inversely proportional. Why? Because in the case of the rough surface, it absorbs the more dirt particles, so rate of the corrosion is more in case of the rough metallic surface. Whereas polished surface, the rate of absorption of the dirt particles is less, so it is inversely proportional to rate of corrosion. And final one is the nature of the oxide film. Nature of the oxide film will be explained by taking the three examples. That means ferric oxide, and second one is the aluminum oxide, and third one is the molybdenum oxide. In case of the ferric oxide, once the corrosion layer is formed on the surface of the metal, further it absorbs the corrosion, further it absorbs the moisture, the rate of corrosion will be continuous. Whereas in case of the aluminum oxide, once the layer should be formed, it cannot further absorb the moisture, so corrosion can be cut off. Whereas in case of the molybdenum oxide, the rate of corrosion cyclic will be takes place. These three types of the oxide films present in the nature of the metal depends upon the corrosion follows. And next one is the nature of the environment. So the role of the environment corrosion of a metal is very, very important. Environmental parameters like temperature, humidity, pH, etc. play an important role. These effects are discussed under the follows. First one is the temperature. The rate of diffusion increases by rising the temperature. Hence the rate of corrosion is also increased at high temperature. Passive metals also become an active, undergo corrosion. But higher temperature reduces the concentration of oxygen, and hence corrosion is reduced to homogeneous solid solution. Hence no local action and no corrosion. That means temperature is directly proportional to the rate of the corrosion, but in the case of the concentration will be reduces. And even the passive metals, that means the passive metals means less reactive metals also more corrosion rate when temperature rises. That means temperature is directly proportional to corrosion. And next one is the humidity of air. In humidity, the gases like carbon dioxide, sulfur dioxide, and nitrogen oxides. Carbon dioxide, sulfur dioxide, nitrogen oxides are dissolved, which form the electrolytes. It will cause the galvanic corrosion. Some oxides of water soluble humidity washes away the action of the products, and metal surface is further corroded. Other corrosion products can also be washed away by the humidity. That means in the presence of the electrolytes, it should be directly proportional to corrosion. And next one is the impurity of the atmosphere. The pollutants like hydrogen sulfide and sulfur dioxide and carbon dioxide. All these are the most pollutants present in the environment. This type of the carbon dioxide and sulfur dioxide gases released from the so many vehicles, and hydrogen sulfide gas will be absorbed from the rotten egg smell, and acid vapors like releases from the so many industrial processes cause the more pollution where they can dissolve in the atmosphere. In seawater, salt nature which acts as an electrolyte. That means salty water, sodium chloride, salty water which acts as an electrolyte. So corrosion rate automatically increases. So suspended particles are dissolved in the humidity and from the electrolyte, which helps in the corrosion. Even in the case of the atmosphere also, because of the presence of the pollutants and presence of the salt, again the corrosion rate will be increases. That means impurities are directly proportional to corrosion. And final one is the pH value of the medium. pH value means concentration of the H plus in the acidic nature. That means pH is defined as a reciprocal of the logarithm of the H plus ion concentration. That means the concentration of H plus ion is inversely proportional to the pH. In acidic medium, pH less than 7, corrosion is the faster. Also, in basic medium, pH greater than 7, some metals such as lead, zinc, aluminum, etc. form complexes and hence they can corrode. That means because of the metallic nature and value of the pH, the rate of the corrosion depends. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.